Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 4 of International A-Level Edexcel P4 January 2022 paper. So it says that a regular icosahedron of side length x centimeter shown in figure 1 is expanding uniformly. So this icosahedron is basically a solid figure with 20 plane faces, all right, especially with equilateral triangles. So the icosahedron consists of 20 congruent equilateral triangular faces of side length x centimeter. So the requirement of part A is to show that the surface area A centimeter square of the icosahedron is given by A is equals to 5 root 3 times x square. So here we have basically 20 equilateral triangles. So first of all, we are going to find the area of one equilateral triangle, and then we will multiply it with 20 so that we get the total surface area of this icosahedron. So as we know the fact that the triangle is equilateral, which means all sides are equal, which also means all angles are equal. And since the sum of all angles in a triangle is equals to 180 degrees, therefore we can say that each angle is 60 degrees. All right. So now according to sine rule, we can find the area of one equilateral triangle, which will be equals to half multiplied by x multiplied by x multiplied by sine 60 degrees. So area of one equilateral triangle will be x square over 2 multiplied by under root 3 over 2. So therefore we can say that under root 3 over 4 multiplied by x square. This is basically area of one equilateral triangle. So the surface area of the icosahedron A will be equals to root 3 over 4 multiplied by x square multiplied by 20. Since the icosahedron consists of 20 equilateral triangles. All right. So the surface area A will be equals to this under root 3 over 4 will be multiplied by 20, which is supposed to be 5 root 3, and therefore area is equals to 5 root 3 multiplied by x square. We have shown this. So here we have the answer of part A. So now let's move on to part B. So here we have some information before part B. Given that the volume V centimeter cube of the icosahedron is given by volume is equals to 5 over 12 completely multiplied by 3 plus root 5 multiplied by x cube. So in part B, we need to show that dV over dA is equals to 3 plus root 5 completely multiplied by x divided by 8 root 3. So here I'm going to do the working for part B. We need to show the dV over dA function. So as we know that area is equals to 5 root 3 multiplied by x square. So first of all, we are going to differentiate a with respect to x so that we get dA over dx function. So this will be 2 times 5 root 3 multiplied by x raised to the power 2 minus 1. So therefore, we can say that dA over dx is equals to 10 root 3 multiplied by x. This is the dA over dx function. And then we have volume is equals to 5 over 12 is completely multiplied by 3 plus root 5 multiplied by x cube. So first of all, we are going to find the dV over dx function. We are going to differentiate volume with respect to x. So this will be 3 multiplied by 5 over 12 multiplied by 3 plus root 5 multiplied by x raised to the power 3 minus 1. So this whole thing 5 over 12 completely multiplied by 3 plus root 5 is a constant in an exact form. All right. So dV over dx will be equals to 15 over 12 multiplied by 3 plus root 5 multiplied by x square. So therefore dV over dx is equals to 5 over 4 completely multiplied by 3 plus root 5 multiplied by x square. So now we have obtained dA over dx as well and dV over dx as well. And now we are going to find dV over dA. And for that purpose, we are going to use the formula of chain rule. So I'm going to erase the working of part A so that I can continue the working on the top. Okay, so in order to find dv over dA, we will use the chain rule formula dv over dx multiplied by dx over dA, such that dx and dx will be cancelled out and you will be left only with dv over dA. So dv over dx is supposed to be 5 over 4 completely multiplied by 3 plus root 5 multiplied by x square, and then it will be multiplied by dx over dA, and since dA over dx is 10 root 3 multiplied by x, so therefore dx over dA will be 1 upon 10 root 3 multiplied by x. So therefore we can say that dv over dA is equals to 5 over 4 multiplied by 3 plus root 5 divided by 10 root 3, and this whole fraction is basically multiplied by x. Okay, so now we are going to simplify the constant term. So here we can see that 5 times 1 is 5 and 5 times 2 is 10. So therefore we can say that dv over dA is equals to 3 plus root 5 completely multiplied by x, and this is divided by 8 root 3. So therefore we have shown this particular form which was required in the question. So this was the answer of part B. So now let's move on to part C. So here we have some information before part C, that the surface area of the icosahedron is increasing at a constant rate of 0.025 centimeter square per second. Okay, so the surface area is basically increasing at a constant rate. So we can say that dA over dt is equals to 0.025 centimeter square per second. So the requirement of part C is to find the rate of change of the volume of the icosahedron when x is equals to 2, giving your answer correct to two significant figures. So this means that we need to find the dV over dt value. Okay, we need to find the rate of change of the volume, obviously over the period of time. So we need to find the value of dV over dt. So I'm going to erase the working of part B so that we can solve part C on the same page. So we want to find dV over dt. It is unknown, and dA over dt is given to us in the question, which is 0.025. So in order to find dV over dt, we can use the formula of chain rule dV over dA multiplied by dA over dt, and therefore dA and dA will be cancelled out and you will get dV over dt. So in order to find dV over dt, we are using the chain rule formula over here. So as we know the fact that dV over dA function is 3 plus root 5 completely multiplied by x divided by 8 root 3, and this will be multiplied by dA over dt, which is 0.025. So we need to find the value of dV over dt when x is equals to 2. So in the dV over dA function, we are going to substitute x is equals to 2. Therefore, 3 plus root 5 completely multiplied by 2 divided by 8 root 3 multiplied by 0.025. So all we need to do is just evaluate this value. So 3 plus root 5 completely multiplied by 2 divided by 8 root 3, and this is multiplied by 0.025. So put this whole thing in your calculator, and therefore we get a value of 0.018894, and so on and so on and so on. And since we are required to give our answer correct to two significant figures, therefore we are going to say that dV over dt is equals to 0.019 centimeter cube per second. This is supposed to be our final answer correct to two significant figures. So this was part C. So this was the question number 4 of International A-Level Edexcel P4 January 2022 paper.